scale, nominal scale, interval scale. We talked about different scales. And then, we discussed how to design a questionnaire, right? I also showed you some websites where you can learn how to make proper questionnaires, right? So today, what we are going to do is, once we collect data using a questionnaire, or we conduct an experiment and we collect data, then how do we, analyze the data? How do we make, some sense out of the data which we have collected? That is what we are going to do in data analysis. Now, data analysis is an ocean, okay? And we are dedicating 2 sessions to data analysis. And as and when we go ahead, we have some applications research chapters coming from the next class onwards. So whenever I feel that, okay, for this application, say for positioning or quantitative in advertising, if I can show you some, data analysis with some data which I already have, I will be performing data analysis as and when those chapters come, right? I think the next chapter is advertising research. Then there is something in brand equity and corporate brand equity and all that. So we will see if we have good data. I will show you at that time how to do data analysis using SPSS, and I will show you that. So because data analysis, generally I teach in 10 sessions of 2 hours each. So we cannot cover data analysis in a lab format or a practical format in our 2-hour session. So according to the syllabus for this particular course, what we are trying to do is, we will try and figure out the importance of data analysis, how data is generally presented, right? What are the what are the major data analysis techniques which can be used in marketing research, and what are the applications of each of these statistical analysis. So that is how the discussion on your chapter is. So today, what I am going to do is, I have a PowerPoint presentation, and also I have your textbook, which is opened here. Okay, so I am going to first, go to your textbook and show you what is there in your textbook, because I think you need to study your textbook well for this chapter. So first, let me take up that. Okay, can you see this class? Your textbook, can you see this? Okay, so it's a new share. Okay, 1 second. Okay, you cannot see. Could you see that? Sanjay Ranjan, could you see the? Where is it gone? I wanted to show you that. Now can you see? Okay, I have to see the chat window also somewhere. Yeah. Okay. So why, ma'am, this is 4th sessions, right? 4th day, and session 7th and 8th, I think so. Right, and chapter number is 7, I think. So you can see, are you seeing marketing research slide or your textbook? I want to show you a textbook once. What is the number of this? Data analysis 135. You're seeing the market research slide, class? Oh God. Okay, you know why I am showing your textbook visible, thank God. Why am I going to show you this? I don't know how I'm going to finish the whole thing today. So if it goes a little, extra, I may be able to complete this only in the next class, maybe the first 15, 20 minutes, okay? But I'll try and finish it. Wait. Okay, so this is your chapter, okay? Data analysis techniques. Now in this chapter, okay, so this is the way your chapter is. They start with a discussion of frequency distribution. So this slide is actually, this is there in the slide. Okay, so generally they start with, whenever you have the data in hand. Okay, so now listen to the class recording. It's very important. When you are actually preparing for this class, maybe you can start with the recording, what you have actually recorded. Listen to that. Okay, so whenever once now we have collected the data has come to us and we have entered the data, okay, into SPSS, Statistica, or whatever analysis tool we have. So after, this class, I will ask you, all of you download SPSS student version, free download, okay? So there is Windows or Mac, whichever computer system you have, you can, download SPSS free download for students version. You download it and keep it in your system, right? And then as and when I go to the application classes and when I show you the data, you can, once the class is over, I'll send you the data. I'll ask Mithal to upload it. You can take the data. The data will open only if you have SPSS installed in it, right? So then, you can run the same analysis and, see the data and interpret on your own. If that is only if you're interested in marketing research, to take it up as a career and all that, right? So here within the purview of our class, within the perimeters or scope of our class, we don't have data analysis, with a software. Okay. So once you, get the data, you have to actually first, clean the data. So today, earlier we will manually collect data in questionnaires, right? And so that means we will manually number. So when I did my PhD, I collected data online also through SurveyMonkey, and also I had collected a lot of data manually. So, all the manually collected data, I will number them. The moment I get a questionnaire, I'll number them as 1, 2, 3, 4. See, if I have 300 questionnaires, which has come back, I will count them. First is I will number it, so that 30 questionnaires I've entered, and then fan blew up all the papers here and there, and then I will not know, okay, which questionnaires I've entered, right, at the end of the day. So because I know that, okay, 30 I've already entered, I have to only start from 31. So this is the first simple rules. So first is you have to number the data. Okay, what is this? Khalid Shah. Ma'am, most of the topics of this chapter we have already studied in decision science. Okay, but then there are also students in the same class who are from semester 2. You must be in semester 5 or 6, no, Khalid? Semester 4. So there are many students who are in semester 2. Yes. So I cannot, yeah. So it might be a little bit of a repetition for you. No problem. You did not know. Okay. So first you listen to what I'm saying. So once you enter the number the data, and then now you start entering the data. As and when you start entering the data, you will see that some questionnaires are incomplete, right? Some questionnaires, certain answers are not certain questions are not answered. So if you feel that, okay, this questionnaire is so incomplete that I cannot actually enter it as another questionnaire, so you have to discard it. Okay. So you are discarding incomplete questionnaires. You are discarding, questionnaires where certain important, parts are not actually answered. So you have to use your, the data entry operator will be actually briefed by the researcher that, okay, what are the most important things in this particular, research. So like, say, for example, I told you, if you are measuring the customer satisfaction of an airline, customer satisfaction is a dependent variable. So there has to be a question in continuous scale on a scale of 1 to 5, 1 to 7, or 1 to 10. I feel the my satisfaction towards this airline is this, okay, from a very and very highly satisfied to very highly dissatisfied. So if this question is not there, this is actually the dependent variable. You will be trying to correlate this question with, their quality of the food, ease of boarding, their in-flight experience, their pre-boarding experience, post-flight experience, all these independent variables, you will be actually correlating to the final dependent variable. So if your, respondent has not answered, this particular question, that what is his final satisfaction, okay, towards that airline, then you cannot use that question. So when you are actually entering the data, you have to tell your data entry operator which is dependent variable, which is independent variable, which are very important. If question is not answered, we cannot be using it, right? And then because they also become very seasoned over a period of time, so they might ask you if they have a doubt. And secondly, once you do this, so this is one very important thing. And then secondly, so these things are actually given in your, material, right? Okay, what you should be looking at and all that. And because why, when we go to the slide, we don't want to spend a lot of time looking at slide, to be cleaning it and removing it. And so that we can look at something which is more important. Now, once the numbering has happened, then you can actually go ahead with the second one. Each question, how important it is. And if you have done it online, right? Online, most of the work is done online. When there is so much missing data, you can even ask, when you get all the data, you can actually put commands in which you can remove questionnaires with missing data. You can do all that. Online, it is easier. Now, another very important thing, for you is, once you, start entering data, you need to code, the questionnaire. Say, for example, okay, let me just show you here. Okay. Okay, so now, I'm just going to show you how coding and all is done. So once this is done, then you have to do code the data. So for example, we have asked the respondent, okay, so what is your educational qualification? Okay, I'm just showing you one or two educational qualification. So when you have SPSS, very easily, you will know how to do that. I will show you, as and when we go, if there is an application, I'll show you. So educational qualification, we have given them options, okay, up to 12th. Then we have given them graduation. Okay, then we have given them post-graduation. Then we have given PhD. Like this, we have given them 4. Right. So now, because this is very important to us. So when we are actually going to identify, say, for example, banking, services, and we want to see what kind of customers are usually using, digital banking or e-banking more profusely. We can see that, okay, how many people up to 12th are using it. how many people who are only graduates who are using it, how many people. So, some kind, or, say, for example, you are Amazon and you want to see what kind of books are read by, people who are postgraduates. Are there any books which are being read by people, below 12? So you want to match this. That means, you need to match their educational qualification with their reading habits, right? So now up to 12th, they will only tick mark on that. Okay, so there is this person, there is this, one person, Ramesh, right? Ramesh has, entered the, Ramesh has entered the data and he has ticked on this. Okay, he has ticked on this. So Ramesh, his education qualification is up to 12. And then there is this fellow here, there is one or two people with graduation, two with post-graduation, one with PhD. So we cannot, be writing down anywhere. When we are entering the data, we cannot be writing down how many people have got, how many people actually have got qualification up to 12. We cannot write Ramesh there, right? We need to give it a code. So I'm now going to give a code. I'm now going to give a code for each. So one second, I have not put the chat option there. Yeah. So if they are up to 12, our code will be 1. If they are graduates, so we are taking the second questionnaire, and that is entered by a graduate, right? So we are putting a code 2 here, and then we are putting for post-graduation code 3 here, and then we are putting for PhD code 4 here. Are you seeing? Okay. So now, is there any value for this numerical numbers? Is there any valuation for this? When we are actually going to do data analysis, are we going to say 2 is bigger than 1, 3 is bigger than 2, 4 is bigger than 3? Is there any value for it? No, it is just a nominal variable, right? So this is actually nothing but we call it nominal data. You remember from our last class. This is a nominal data. Here numbers are just names. Names or just labels. Okay, so so this is actually a discontinuous variable, or this is a nominal data. We cannot use them for any major statistical analysis. Here, what we can do is, when we have a data, we have entered, so we understood that there are 400 people. We had a sample size of 700. 400 people were up to 12, okay, and 100 were, say, graduates, and so that makes it 500. Then we have around 100 were postgraduates, or 150 were postgraduates, 50 were PhD. So now we have got what is called as numbers. We know for, okay, how many 4s were there, how many 3s were there, how many 2s were there, and how many 1s were there. So this is what we have put up is, we have absolute, numbers. That is mode. We have mode, the numbers or the counts of each group. Okay, so what we can do is we can just count the numbers. So this is actually, so mean, median, mode, what is it? It is frequency distribution or measures of dispersion. So coding is extremely important. Okay, so once you like this, you will code the data, right? So you can only be, entering under educational qualification. You only enter 1, you enter 2, 3, 4, like the way you enter in Excel also. So these are, things which are very important. So once you code the data, so once you, then first you clean the number the day questionnaire. Second, you clean the data. Third, you code the data appropriately. Then you are actually going and you are going to start doing your data analysis. So in your textbook, how it is actually given is some problems are also given. So when it comes to the problem, I will go into the textbook and I will show you, right? They have actually, maybe, for your exam, if they, can keep a problem, you can actually solve it. So therefore, I will go back to the slide and show you that. So, so this is the first thing you can do with the data, that you can actually see what is the total sample size. So, that is the total sample size is known as N. Okay. So if there are 700 people who answered your question and you are going to take around 600 questionnaires which are duly filled, appropriate, after cleaning. So 600 becomes your sample size. So you discarded, 100 questions. So now 600 has become your sample size. So that is represented by N. And within that, you might ask how many are males, how many are females, how many are other gender. You have to actually, you might try to describe your data. How many people are postgraduate, how many people are graduates, right? How many live in a city, how many live in a metro, depending on what kind of research you do, right? So these are actually describing your data. You are actually describing your data. So these are called as descriptive statistics. So your mean, median, mode, and these kind of measures of central tendency, you will actually use to describe your data. So now let us read and see what is there in your slide. So is it clear till now? So the analysis of the collected data is one of the main activities of the marketing research process. Frequency distribution is one such statistical analysis technique, and it can be defined as an organized tabulation or a graphical representation. So first, when you actually present your data, say if you have a class project, first when you do the data analysis representation, these are the things you should do. You should describe the sample. So the first paragraph will be that this was the sample size. We collected 700. We had to discard 100. Now we have 600. Okay, out of which so many were men, women. You can use a graph or a table and to explain. So now let us try and see. Okay. So first you start with, this description of your sample. So now, now the most commonly used display modes are, you might use frequency tables, and then you might use frequency distribution graphs. So this, men, women, and other gender. So if we have that, you can put it as in a table, right? Men, out of 600, we had 400 men, maybe we had 195 women, and maybe 5 people of other gender, because now they use other gender. When every modern survey, they always ask people to choose the gender. So you can put it in table, or you can also put it as a chart, right? So under chart, it could be a histogram, or it could be a frequency polygon, or it could be box and whisker plot. So in the textbook, they've actually given you a little bit of example of box and whisker plot. So this is the way a box and whisker plot look like. How histograms look like, no? So histograms will look like, like this. Say for example, look at the shape. So it's like so I think from school we have learned this, histogram. So here the textbook, they have given a little bit of explanation on box and whisker plot. So this is how your box and whisker plot will look like. Now we will go to your textbook to see. Where is it? Yeah. Yeah. So this is your box, and you can see this, no, class? Okay, so John, so what should I do now? Should I teach you, or there are students in this class who are also done since semester 2, right? You tell me. Really, I'm really surprised. If you have already studied, then you speak, you take it up with your course, coordinator, right? Okay. So, yeah, so why am I doing this? Because I think I was told that students learn from their self-learning material. And, you have to teach the self-learning material because that is what we are going to cover in the exam. Correct? So that is exactly the reason why I'm just going, because somewhere somebody might find it a little difficult. Yeah. I am not irritated, but I want you to understand, you need to have patience. You're not postgraduate students, right? You're not students who are in 11th and 12th and all that. If you know, great, good, go ahead. Study far ahead of this. Data analysis ab kidhar aage badh gaya hai, right? Okay, so now if you look at the box and whisker plot, so this is how your box and whisker plot will look like. So in the middle, you have the median. Okay, so median is mean, median, mode. So that also is coming after this. It will come. So mean is once you collect the data, you think that your distribution is generally normal, right? So if your sample size is above 30, there is this tendency that most of the data we collect will be will be hanging around the mean of that the distribution. So therefore you have what is called as a bell curve for normal distribution. So in a normal distribution, you will have a mean, you can have median, right? That is the middle data, right? Which is the middle data. And then you have mode, the number of times frequencies are occurring, like how many men, how many women. It answers the many questions. Now, for in the box and whisker plot, what you have is you have the median here, right? And then you have the outliers. So you have the lower quartile here, you have the the upper quartile here, and between the lower quartile. So lower quartile is your first 25%, your bottom 25%. Upper quartile is your 75 to 100%, okay, of your data of your data points. And then between your 25 and your 75 is where your box lies, okay. And so this is how whisker plot looks like. So now let us go a little ahead and see. Okay, now if you look at it, you can see that, you can read that. So I told you the 75th and the 25th percentile is this. Okay, so this is your first 25th, and this is from your 75th to higher. So now once the length of the box estimates the variability of the data. So this is the length. Can you see Q1 to Q3? This is the length of the data. It actually tells you, okay, where exactly, what is the variance of the data, right? So, how do you actually represent the variance in a whisker and a box and whisker plotters? You use something called as interquartile range, right? So that is from Q3 minus Q1. You do this. This is your range. So this actually makes more sense than a regular range which we do in frequency distribution. We take the highest number and we take the lowest number, and then we minus. That is our range. This is actually more qualified because it removes maybe some of the outliers from both the sides. So then you have an interquartile range here. So it is written here. So the line inside the box highlights the median. So here the median is towards this side. Okay, the position of the median reflects whether the data are skewed or not. If the median is near the upper quartile, then they are negatively skewed. And if it is near lower quartile, it is positively skewed. So so if it is standing to one side, that is skewness, right? So if it is positively skewed or negatively skewed, you can just represent it by putting up a plot, like this. Immediately people will know, okay, what is the skewness. So the lines outside the box on the other side are called whiskers, which are 1.5 times the length of the box. So these lines are actually what is called as the whisker. So this is outside the, outside the box. So this is called as the whiskers. So this is not very popular. I have not used this technique much, but I think because this is in your textbook, it's good that you need to know about all this. So, now, how if it is towards this side, what it is, and all this is actually given in your textbook. So, okay. So then, okay. So then now again, go back. Why I'm showing you, because these explanations are not there. So this is the box and whisker plot. So it gives you a representation. So, so this actually is the whisker, the outliers, right? So if it is, so there is 95% confidence level, 99% confidence level, you can have those kind of indications depending on, whether it is 1.5 IQR or 3 IQR. So read it a little bit, it is not very, it's not explained in detail. You can take it from your, textbook. Okay. So now, we come to what is called as practical applications. I will come to practical applications. You know why? So what is the time now? Tell me what class, what is the time? Okay, 7:37. Now listen, we have 2 hours and we have to finish a chapter on data analysis, correct? And your data analysis chapter has so many things. If a student who has not studied statistics, if they want to give an exam, it will be very difficult for them if I don't explain. Now, I know the importance of data analysis and its practical application because I teach marketing research using SPSS, right? So how you are actually doing the theory part, right? So I will give you half an hour. I've made extra portions and I have also promised you, because in my next class onwards, I'm doing applications. If you read your SLM, you know that from next class onwards, we have applications. So we can actually take, time, and every time we are doing some, application, we can use some small case study kind of a thing and discuss it. But today, first I will finish this and then maybe half an hour. I put extra portions for you so that you can also have a look at it, at leisure. Is it okay, Khalid? Because I think this SLM thing is also very important for me. Okay, so then you have what is called as your frequency distribution. So that is your mean, median, and mode. So which also you need to actually be writing down. As I told you, what is the mean value? So customer satisfaction. So what is the mean value? Your scale was 1 to 7, and you calculated the mean value, and it came out as 5.3 with a standard deviation. You have a standard deviation value. So you have to write down what is the mean. Okay, how many people gave you the answer 1? How many people gave you 2, 3, 4, 5? That becomes your mode, right? So what was your, so these kind of things you have to actually report, which generally the data analysis software will give you. And these kind of simple things, Excel does it for you. Excel will do up to regression, Excel can do. You can use Excel and do data analysis, okay? So then, so this is your mean, median, mode, which is known as the measures of central tendency, which you have already done. So I already told you what is mean. So mean without a coating of standard deviation does not have any meaning. So what is standard deviation and mean? Let us have a, okay. So this is, so I hope class, so you all know what is mean, median, mode, right? Maybe, when we do an application, I will show you a data analysis output. And then I'll show you how the data is reported, right? I'll try and show you that. So now, okay. So once mean, median, mode is quoted, then you have to quote the range. What is range? Range is the value of the highest data minus the value of the lowest data, right? So that means, but ma'am, in exam, we have to do manually. So you do manually, na? It is so easy. I will show you. They have given some example. Their example is solved. The example is actually solved in this SLM also. 1 or 2 examples are there. It's very simple. There is only, there is an equation and you have to make a table and I keep entering it in the table. So, that this is your range. Range actually gives you an idea about, which is where exactly the data lie, as in boundaries, highest value to, lowest value. Then you have to, standard deviation. What is standard deviation? What is standard deviation, class? No idea what is standard deviation? Okay, I'm not asking any formula. Formula is given in your textbook. Standard deviation is, say you have a data point, right? So we have so many data points. So let us show this. So, okay, so this is, can you see this, the middle curve, this mesocortic curve? This is the way the normal curve looks like. Okay, so this is the way the normal curve looks like. Now, any data in social sciences where human beings, we're collecting data from human beings, mostly what has been seen is, if you have a sample size above 30, right, the tendency of the data is to form around the mean. So most people will generally give an answer towards the mean. So this is the mean of the, the data points, right? So that means, what is mean? Total divided by number. So most of the answers will lie around the mean. I'm talking about this particular curve. So the most of the, answers will lie around the mean. Now, say if there is a point here, and this is the mean value. If this is somewhere the mean value is, now the distance between this point and this mean value, okay, that is standard deviation. So if there is a point here, right, and so the distance between that and the mean value, right, so that is standard deviation. So if most of the points are here, and so that means if this is where the mean is, somewhere here, if this is where the mean is, see a point here, 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 the distance will be small. So that means mean actually represents all the data. Mean is actually a real response of all the data. Okay, so only if you have a normal distribution, mean has any value, right? If it is not a mean, normal distribution. So first we have to actually check whether your distribution is normal, right? And mostly above 30, all the data tends to look like a bell curve. So standard deviation is the distance between each data point and mean. And in a perfect normal distribution, most of the points will lie towards the mean. Therefore, the entire, whatever you say, okay, as an average representation from the sample will be a real representation of what people have said. But there might be some people who gave an answer, somewhere here. Okay, their answers will be here, and this is where your mean is, or somewhere here, and this is the distance between your mean. So who are these? What do we call these points which are on these extreme sides? What do we call these points which are on the extreme sides? So there is a point here. There's a point here. What do we call these points? So if there is someone in the class who feel that no, this is not to be taught. So if that person is here, okay. So he gives, this said, okay, 1. So that means if that is an extreme answer, right? What do you call this? Extreme points in normal distribution. Anyone? Extreme points in normal distribution. It is known as outlier. Okay, it is known as outlier. So it will be somewhere. So you are not actually, so when we are actually cleaning the data, we can actually cut the outliers also, right? And then we can actually look at the mean as a more robust, quantity. So here, you can, so that is standard deviation. If the standard deviation of the data is very high, almost as big a quantity as mean, okay, in comparison, is it good? Is it a good sample? If the standard deviation is very high, is it a good sample? Standard deviation is high, is it good, Rima? So that means most of the points are lying far away from the mean. Standard deviation is high means the distance between the mean and different points in the data are high. Is it very good? No, because then mean is not a real representation of the data. Are you getting what I'm saying? So one is we know things in statistics. Second is how we are understanding. Okay. So did you understand standard deviation? I mean, so if your data has got high value of standard deviation, so if your mean value is 5.4, so you had a scale of 1 to 7, and your mean value is 5.4, and if your standard deviation is 4.9, if it is, okay, so that means it's very, very close to the mean. So the number is very as big as the mean, okay. So that means, you know, your data is actually not really good. Many people have different viewpoints in that particular data set. Correct. So these things are very important. And then mean deviation is the absolute distance between each data point and the mean. So, you know, when you quote, you have to quote, you know, the standard deviation for every variable along with mean. And then, you know, okay, so then there is a discussion in the textbook about different types of shapes, okay, of your frequency distribution. So mostly what we get is a normal distribution. But in some cases, you know, your mean value will be much above, you know, a regular mean which you expected. So that will be known as a leptokurtic mean, right? So it will shrink and narrow a little bit, you know, towards the top. And then, you know, there could be another type of, you know, distribution where in which it becomes flatter. Your mean becomes, you know, this portion becomes flatter, right? So that is called as platykurtic. So you can learn it all, you know, this is semantics. And then, you know, go to, so this is first, so data cleaning is done, coding is done. Then you have described the data in terms of what is the constituents of the data, both in interval variables like satisfaction or in nominal variables like male, female, you know, all this, and education qualification. Now you have done all this. Now we are actually going to to a stage where we are going to do real hypothesis testing, right? So first, let us try and understand what a hypothesis is. So before, you know, taking you to the you know, to the slide, I am going to discuss a little bit of hypothesis testing. Okay, is there anyone who has an idea what a hypothesis is? Okay. So hypothesis is something which you are not sure of, right? You need to test it. Okay, so you are actually proposing, you know, a statement based on, you know, based on your understanding, you know, about certain things. Say, for example, you feel that in developed markets or developed countries, you know, I am a very big stock market investor. Okay, so most of my hypothesis will be on that. Okay, it is an assumption. When you have not tested it, it is an assumption. So I am now writing down an assumption. Okay, Sanjay. So developed countries will be more will adopt so this is, I have just made a prediction. So this is my prediction. Correct. So what am I saying? Developed countries adopt cryptocurrencies in the initial years. ये मैंने बोला है, ये मेरा assumption है ना? It could be true, लेकिन social scientists will not agree to you unless otherwise you prove it with data, Puneet. Okay, unless otherwise you prove it with data, they are not going to agree to this. Correct. So when I teach market research in class, we will start some segmentation, positioning. I will show them a problem, and they'll say that no, this market can only be divided into three groups and all that. And when we enter the data and do the data analysis, you will see that there are maybe 4 or 5 groups in that market, right? So till we analyze the data, we don't know. That's the reason why we always need to analyze the data. So this is I have now made an assumption. What is this assumption? Developed countries adopt cryptocurrencies in the initial years. This is an assumption by me. The moment I am ready to test it, right? So this is in your textbook. There are definitions and all that, but why am I telling you all this? You can easily understand this like this. So now the moment I am ready to test it, when I am ready to test the above assumption, or statement, assumption or statement, it becomes a hypothesis. How am I going to test it? Test the above assumption with data. Okay, now it has become a hypothesis. Okay, so before that, we call this as a proposition. Okay, so in research, first when I'm making a proposition, I make a proposition. What you call an assumption, that is called as a proposition. So proposition will always come from theory. I have some who said Puneet. Puneet said, no, this is true. Because Puneet knows that, okay, there people have got more matured investment strategy. They know that, the regular currencies are actually not going to be of much value later. So people will go into digital currencies, which everybody can use in the world, right? So therefore, crypto will come, so you are actually making a theory based on all the things which are important and relevant to you. From past data also, you have actually taken things and then you have made a proposition. So proposition should have sound support of theory. Okay, class. So now, so that this is your proposition, right? So this is my proposition now. And when I am ready to, and now when I am ready to test this, proposition, this statement has now become a hypothesis. Is it clear now? It has now become a hypothesis. So now when I'm going to test it, right? So if I test, so I am going to test it. What could be the test outcomes? Class, what could be the test outcomes? Either what I said could be true, or what I said could not be true. Correct? Yes or no? Adoption is true. What? Yeah. So how many outcomes could be there for this? 2 outcomes. So the outcome 1 is, outcome 1, what I proposed is true. Okay. What is outcome 2, class? What is outcome 2? Not true. Yeah. What I proposed is not. Okay. So this is a very simple way of telling you. Now you listen to what I'm saying. Now you listen to what I'm saying. Okay. Now, so there could be two outcomes. One is outcome one, what I proposed is true. So, and what is outcome two, what I proposed is not true. So that means if it is not true, nothing has changed in the world. Correct. जैसा था हमें पहले भी कुछ पता नहीं है. We don't know anything about cryptocurrency earlier as far as developed countries and adoption is concerned. Now also we don't know anything. All we know is that what she said was not true. Correct. So when what I suggested does not become true, nothing, everything is the same as far as knowledge is concerned. Okay. So now I will take you to the concept of null and alternate hypothesis. So what I suggested, what I proposed, is what? Okay, one second. First, let me see this and then we'll discuss. So what I'm just teaching you what is mean by proposition, what is mean by hypothesis, what is mean by null and alternate hypothesis. Okay. Now, so now what I proposed is called as alternate hypothesis. Whenever you propose something from something which till now no one has tested, or on this data sample no one has tested, you are actually proposing something that is known as the alternate hypothesis. Okay, that is known as the alternate hypothesis. So then developed countries adopt cryptocurrencies in the initial years. So this I have actually proposed. I'm doing a study or something. So I have proposed. So what I have proposed becomes alternate hypothesis. So this is our outcome one, no? In this example. No? So this outcome one does not have any theoretical meaning. This is our outcome one. Okay, what is outcome two? There is no significance between development, a country's I'm just writing. You can just develop countries and adoption of cryptocurrencies. Okay, developed countries So if you look at it, there is absolutely no connection. Whether the country is developed, there is no connection with the adoption of a, I will tell you, Puneet, I'll tell you how we can analysis. Or do you want to say something? So here, one is what I said is correct. Okay, so that means that is what I stated. That is the alternate hypothesis. Second is there is no connection. Nothing changes. What I said and what about is the adoption of the cryptocurrencies, there is no connection. So that is null hypothesis. Then I'll show you simple null hypothesis and okay. So this is your null hypothesis and this is your alternate hypothesis. So when whatever you have suggested, if it is not relevant, whatever earlier was, it remains, right? That is null. Fact till that day remains the same. Whatever you have suggested has not come true. So this is your null hypothesis. This is your outcome. Outcome two. Okay, this is your outcome true. Okay, so one is what I made a proposition, and then when I'm ready to test that proposition with data, it became a hypothesis. Then once I'm ready to test the data, okay, so that means, the hypothesis may have two outcomes, outcome one or outcome two. One, what I said is true, right? So, and the other outcome is what I have said, is not true. So the status quo remains. So what I propose is known as the alternate hypothesis, and the opposite is null hypothesis. Okay, so in data analysis, we always test the null hypothesis. We always write down both alternate and null hypothesis. We test the null hypothesis. We say either we reject the null hypothesis or we do not reject the null hypothesis. Now, okay, so Puneet, what is it that you want to ask? Tell me, I did not get your question. But ma'am, there is different opinion how we can analysis. Tell me, what is your question? Be a little more clear. About cryptocurrency. Puneet, I just used it as an example. Okay. So let us not go there now. Okay, so now in a very simple way to make you understand hypothesis is, say for example, so this is something which I read somewhere, very simple way. So you are, say for example, you ask your father, can I go for a movie? Okay, so then there is always two outcomes, no? Either he can say yes or he can say no. Right. So, you should be able to read. So as a researcher, you should be like this to, this son who asked the father whether I can go for the movie. The father say yes, you can go for the movie. If the father say no, then you can't go for the movie. You cannot stand and, argue there because he has said no. So exactly like that, the researcher, when he is actually stating an alternate and null hypothesis, he is actually trying to understand, okay, this is what theoretically I feel. Okay, there is some connection between developed countries and adoption of cryptocurrency. So he went, collected data from developed countries, and he must have also data from developing and underdeveloped countries, and then he would have tested and seen that okay, the variation is almost similar everywhere. So he might, his data alternate hypothesis would have got rejected. Or he would have understood that adoption of cryptocurrencies in the US and UK and all these kind of European countries are much higher than than in countries like India or Bangladesh and these kind of countries. So that means there is some connection between developed country and adoption. So in that particular case, his null hypothesis stays rejected. And what he said and what he proposed is the same. So is it clear now what is null and alternate? Just write yes or no comment there. Only one person. How many people are watching? 20 people in my class today. Ma'am, null once again, please. Okay, so I'll tell you once again, null. So let us take another example. You know what? I'm going to ask them maybe, next class. Yeah, maybe a little bit of time we'll spend more on data analysis because it's so important in market research. Right. So another example for null hypothesis, right? No, you want another example. So let us. What is this? Yeah. So okay. So I am now proposing good ambience good ambience impacts customer satisfaction in a restaurant. Okay, so Rima, now this is for you. So I am proposing this. Good ambience impacts customer satisfaction in a restaurant. So some restaurant study is happening. So they are thinking that, okay, let us have a restaurant where people stand and eat. Okay, and it will not be very pricey, but it will be medium price, right? So another partner is saying that no, let us have a good ambience. Then people will pay more, even if they are standing and eating, they will pay more. So the other fellow says that no, then if we are having the restaurant where people stand and eat, so then we don't need to spend so much on interior. So they're thinking about all this. And if it is a restaurant chain and all that, they would like to see whether ambience will increase the customer satisfaction or not, right? So everything else will remain the same. The price of the the menu, the food quality, everything will remain the same. So now, what am I proposing as the researcher? Good ambience impacts customer satisfaction in a restaurant. So I told you what kind of restaurant. So what hypothesis is this now? Rima, what hypothesis is this? I am proposing this. Is it null hypothesis or alternate hypothesis? Alternate, because you are proposing it, right? So this is alternate. Okay, so this is your alternate hypothesis. Now, what is the null hypothesis for this, Rima? What is the null hypothesis? Yeah, exactly. Good ambience may not impact customer satisfaction in a restaurant. Okay, so if let us now let us write it down. Then we can actually improve and modify this. Okay, got it? No, yeah. So there is no significant. The significant word is so important. No? Significant impact of good ambience and customer satisfaction. Then इसको सब you have to write it better, word it better. You got it, no? And customer satisfaction in a restaurant. Got it, Rima. Okay, so now exactly. So now I'm just did you get it? So this is your alternate and this is your null hypothesis. Okay, now if we want to, if we had a questionnaire and we are going to test the data, so we need to have data on good ambience. Okay, so how important is good ambience to you in in a restaurant where you stand and eat? What do you call these restaurants where people stand and eat? There is a name for such restaurants. Now in Bangalore and all, there are many such restaurants. So so you need to, so the questionnaire you're very clearly writing down, or you can do an experiment also. You can collect data, then experiment also. So you tell all the people who are participating in a survey that you can show maybe a kind of a restaurant, or you can tell them this is a restaurant where this will be the menu and this will be the price, and people will be standing and eating. Do you want very beautiful setting, or how important it is to you? So some people may say that if it is very good ambience, I may think that it is very expensive. So you can do all that, but there has to be something which measures this variable good ambience. Are you getting it? This good ambience becomes a variable here. Good ambience is a variable. You need to measure good ambience. So how important is good ambience to you in a scale of 1 to 7? You should have asked people. In a restaurant where you are going to stand and eat, right? You should write down. And so that means good ambience becomes a variable. Okay. Now, what is the other variable you should have measured in your questionnaire? Good ambience I'm measuring. So I'm going to do now regression or correlation later on this. So good ambience I'm measuring. And I'm also going to measure what? Customer satisfaction. Yes, customer satisfaction. So one more small thing, we go to the next slide. I think we need one more class for this, right? I'll tell them. Variable, where is variable? Yeah. So good ambience is a variable and customer satisfaction is a variable. So both should have been there in your questionnaire on a similar scale, 1 to 7, for both, right? So now, okay, now one more thing I'm going to ask you. Now, one of this is a dependent variable and the other one is independent variable. That means one actually gets impacted because of the other. So the dependent variable depends on independent variables. So which is the dependent variable here, class? Independent is customer satisfaction. Anybody else? Why is customer satisfaction independent? And dependent is good ambience. Which is dependent on which? Does customer satisfaction get affected because of good ambience? What gets affected? Good ambience, good quality food, the right pricing, faster serving time. Yes, Rima. So, customer satisfaction is dependent on good ambience, fair pricing, quality and taste of food, how fast you serve. So all of these 4 things which I described become independent variable. And this becomes dependent variable. Is this clear now? Okay. So now using your test, our test, data analysis, this is exactly what we will be testing mainly. And so you have all this descriptive statistics, frequency and all that we do. And then you use hypothesis testing you do to test these kind of things, which are very, very important, right? So Khalid, what are you writing? Even the service quality of the waiters and the wait time would affect customer satisfaction. Exactly. All of that, so you have 7 P's. Now, restaurant is a service business. So 7 P's naturally, become your independent variable. And your customer satisfaction is your dependent variable. So for pure products, 4 P's to apne aap ho jata hai. Got it, na? Okay, so now we have this strategy. I'm not going to give a break for this class. So if you just want to just go get some water and all, you get. Okay, because I also need to finish. I might have to ask them for an extra class or something to finish data analysis. So okay, so now we have actually cleared, what is hypothesis. We have actually cleared what is alternate and null hypothesis. Now we have discussed independent and dependent variable, right? So we did all that. So now let us look at quickly what your material says. Okay. Can you show last slide again, Dharmendra? Which was the last? This one? This one, Dharmendra? Which one, ma? This one? I'm showing you some slides. This is my class summary, a workbook. If it is, this is in the recording, na? You know what? These things I teach with the board in the class, real class. So now we looked at different normal distribution. I told you what my normal distribution is. Okay. So this is like an ocean class. We just have to do more and more. There's so much to all these things. Okay, now, we look at hypothesis. So now let's just quickly look at what null and alternate is. You will very easily get it. So there are mainly two types of statistical hypothesis. Null hypothesis is, it is defined as the hypothesis that sample observation occur purely by chance. Okay, so it is fact. So sun rises in the morning. Okay, it is a fact, right? You cannot, you can't test it. It's a fact. Okay, so whatever is the status quo remains. That is null. And alternate hypothesis is what you try to propose. You're trying to say that, hey, this is a little different, right? That is alternate hypothesis. So it is defined as the hypothesis that sample observations are influenced by some non-random reason. It's constructed with the aim of accepting the same when the null hypothesis is not true, right? So you are actually, when you do your testing, you are trying to, what you say come true, you reject the null hypothesis. Okay. So then, then there are stages and all that. Let us quickly look at it. So the introduction to hypothesis testing. So first you have to state the hypothesis. So before that, you will have one single statement, which I told you is a proposition, which is supported by some kind of a logic. So in academics, we call it theory, right? So in industry, they say logic. There has to be a logic to what you propose. So you state, once you make the proposition, then you have to state your hypothesis, your null and alternate. Then you have to have a analysis plan, right? So our, our good ambience and customer satisfaction. So we say that we are going to do survey and we are going to measure customer data and data on good ambience. We are going to collect data on the same question on customer satisfaction, and we are going to see whether there is any correlation between the two, whether there is an impact, which will measure through regression. The higher, as and when the ambience go up, does the customer satisfaction go up? We can test all these kind of things. So that is your analysis plan. Then you analyze, then you collect the data. Then, you analyze the data and then you interpret the results. Okay, so this is your, okay. Then, what is it now? Okay, there are then one or two things which you may have, get a question. So this is your type 1 error. So when you are actually making the hypothesis, okay, where you collect the data and when you test the hypothesis, right? After you test the hypothesis, two types of error can occur. Okay, so these are known as the type 1 error or type 2 error, or it is known as the alpha or the beta. Okay, so what is, the type 1 error? So the type 1 error is your, you reject your null. Can you just see this? Okay, so this is what you reject a null when it is true. You are actually rejecting a null when the null is true, right? So that means, I rejected the fact that there is no connection between adoption of cryptocurrency and the development of a country. Okay, so there was actually, the answer was there was no connection. But, I did something with the data, right? And I, ended up rejecting the real null, I rejected the null when the null is true. So this particular, analysis has what is called as type 1 error. So when you reject a null when the null is true, that is called as a type 1 error, right? And the type 2 error is, you reject a null when it is false. So you reject a null when the null is false. So in this particular case, what came out is there is a connection between the development of a country and adoption of crypto. That is actually the one which came true. What you proposed came true. But, the analyst rejected it. The analyst rejected it, right? Because he supported the null when the null is false. So these are two errors which can actually happen in a data. This is exactly the reason why you need to clean the data very clearly. Your 1 to 7, 1 to 8, all these kind of things have to be properly entered, right? So this is So there generally there is always this question, what is type 1 error? What is type 2 error? So this is what type 1 and type 2 are. Okay, now we are actually going into some kind of, once the data is analyzed, what are the kind of things which you can do with the presentation of the data? So I had students like Puneet and all, I think they wanted to know and see this. So let us go and see it. Okay, so one, so I will now just go a little faster so that I can explain to you with examples towards the end. So one type of analysis which is explained in your textbook is cross-tabulation. So cross-tabulation is used by statisticians and data analysts to jointly display the distribution of two or more variables by tabulating their results against the other. So is there an example? Let me see. I will see it in the textbook. Quickly, let us go to the textbook. So they have given you some examples. Okay, so this is cross-tabulation. Okay, so cross-tabulation is, again, you can do it with SPSS and all that, right? You can do it in Excel also if you have the data. So this is, so look at this this problem. Okay, so this is how a cross-tab is done. An example of cross-tab is, which can be a 2x2 contingency table. So what is 2x2? There are two variables here. One is denim and one is cotton trousers. So, so you have a jeans preference. So this is the the pant preference. And then this is the age of the people, right? So there is two variables. One is the preference of a pant and the other one is the age of the respondents or the age of the customers. So what is it? Let us read this. So we can have a 2x2 contingency table where one variable is age group and the other is preference for denims or cotton trousers. Very simple things, right? So, once you ask for a cross tab, so what you will do, you will take cross tab, from your, analysis tool, you will click on it. So if I get time, next class, okay, I'll show you all this. You have to download first SPSS version. I'll also download and show you. So, so you download, you choose cross-tab in the analysis, and then you choose these two variables: pant type, one denim, two cotton trousers. Age, one below 30 years, and the second is above 30 years. So you have two groups. You choose this and ask it to perform cross-tab. Click on cross-tab, say yes. So you get a table like this. What is this? So they want to see what is the preference, of different age groups for different types of pants. So under the, age below 30 years, they went to how many people? 20 people, right? Out of which 14 people preferred denims and 6 preferred cotton trousers. Above 30 years, they again went to 20 people, out of which 12 preferred, cotton trousers and 8 preferred denims. So, when they are actually, going to launch, this particular brand, it's not as simple as that. But then from this table, we can say that when they are going to launch, if they are looking at age groups of, 30 and above, it is better to launch cotton trousers. If they are, planning to launch denims, it is better you target, people below 30 years, right? Or if you want to have both, then what you can do is, if you want to have both, then you can actually launch both and target each of them independent. Okay. So okay, break. You want 5 minutes break. That's what I said. If you want to take a break, you take a break and come, because I don't have time to give a break today. You quickly take a break and come. Okay, so yeah, you all want a break? It's only half an hour now, because I won't be able to finish. As such, I think I'll have to ask for another class, or this will go into the next session, because data analysis requires time to teach. All the other things you can actually read. So, so this is cross tab, right? So you have, different kind of things here. Data cleaning and all is written here in your textbook. It's all written. Okay, then, okay. So now, I am going to, discuss a little bit of, so the Crosstab is one application which you do. Okay, thanks. So Crosstab is one application which you do. Another application which you do, which you can actually do is, you have, say, 2 cities. Okay, I will summarize this in the PowerPoint. I will write and summarize, but you just listen to me. Okay, so we have 2 cities, say Chennai and Mumbai, and a company is actually, trying to launch, shirts. And, so some people who have already knows this market really well, who has been working in this kind of an industry for a long time, they say that, the preference of design, is different in Chennai and in Mumbai. And they say that in Chennai, people like more, they like checked shirts more, whereas in Mumbai, people generally prefer more of plain, shirts. I am just saying, okay. So there is this proposition. So 2 or 3 people who have been working in the industry for a long time are telling, this is important because, if we are launching in these 2 places, we cannot have the same design, in both. At least, there has to be 70-30, proportion higher of one, say, if I'm launching in Chennai, 70% of my stock should be check and 30% should be, plain. Whereas when I'm actually launching in Mumbai, 70% has to be plain and 30% has to be check. It could be like this. So what is it that I am trying to do, class here? Okay, what I'm trying to do is, I have 2 samples, Chennai sample and Mumbai sample. Or I have 2 data sets. I am trying to test, okay, whether Chennai sample and Mumbai sample, are they significantly different from each other as far as the print on the, or the design of the, the material of the shirt is concerned. Is this clear? Is there a significant difference between Chennai and Mumbai as far as the design on the shirt is concerned? Is this clear? So I have 2 data sets, correct? 2 samples. So when I am trying to compare 2 samples, which test do I do? Anyone who has done this decision sciences? I've got 2 different, groups of data or samples of data. I am trying to see whether these samples are significantly different from each other or they are not. So what will be my hypothesis here? Hypothesis is, what I am trying to suggest, alternate hypothesis will be, there is significant difference between the design, liking of Chennai and Mumbai customers. There is significant difference. I am proposing. Okay? And what will be the null? There is no significant difference between the Chennai and the Mumbai customers as far as the design is concerned. Are we getting the hypothesis here? Class. I am only doing blah, blah, blah. और तुम लोग भाग गए क्या सब स्टूडेंट्स डेटा एनालिसिस देके? कितना है मेरे पास? 19 स्टूडेंट्स. Poor Rima, you are my savior. You're answering the questions. Yeah. So, so this is now this kind of a test. Can you see in your textbook here? This is, you will test this kind of, data with a t-test. Okay? You do a t-test. Do you remember all those who have studied decision sciences? Apne kiya rahega na t-test and all that. But you don't know where to use it, right? So when you are actually, so this is one example where in which you can use a t-test. Okay? So you can use the t-test and then you can actually the value. So you can use the p-value significance, whether it is within 0.05, like that. So they're not given examples for all this. They're given only, so they have actually given something very similar. So when you are actually comparing a sample, you are using a t-test. Okay? Then so now we had 2 samples. What if we have 3 samples? So we are taking Delhi, Mumbai and Chennai. So more than 2 samples we use for the same, we use ANOVA, okay, analysis of variance, when we have 3 samples. So this is t-test, this is analysis of variance, then, okay, if you are at the same thing. So for t-test, you are conducting when you have a sample size of below 30. You will do a z-test if you have 2 samples and the samples are above 30 numbers, the sample sizes, that you do a z-test. Okay? So you do a t-test and a z-test. So then, so then some tests are there, chi-square, Mann-Whitney, Kruskal-Wallis. So these are all tests which, you can actually do, where you have nominal data. So the prime requirement for conducting z-test is the sample distribution must be normal. Some commonly used non-parametric tests are chi-square, Mann-Whitney, and Kruskal-Wallis test. Okay, so now we are not going much into it. Chi-square also you would have done, right? What is chi-square test? Chi-square test actually measures the fit. Okay, how, whether, say for example, gender of a person and liking a particular kind of color combinations in interior design, is there any correlation? So gender is a nominal variable, liking to a particular color, is a interval scaled variable, right? So when you have a nominal variable and an interval scaled variable, and which you are actually testing for the goodness of fit, you can use what is called as a chi-square test, right? And then you can also, you have Mann-Whitney tests here when you have rank order data, right? So you can actually do Mann-Whitney, tests when you have, rank order data. So you have, they have explained chi-square test here. They have, see, I told you chi-square test, you can actually read it. Then Mann-Whitney test is also, explained here. It is for ranked variable, rank 1, rank 2, rank 3. Okay, so when you are actually trying to see, say this is also used to test whether 2 sample means are equal or not. It is generally used when the data is ordinal. Actually, rank order data, you cannot take the mean. Okay, so here a little bit of difference is there, but then when you have rank order data, whether you check whether the rank of these 2 brands are significantly different from each other, you're trying to check it, you can use Mann-Whitney test. And then you have Kruskal-Wallis test. What is that? This is another non-parametric test which is widely used when there is one nominal variable and one ranked or rank order variable. That is Kruskal-Wallis. Okay, so one thing which I've not told you is, non-parametric and parametric tests. So parametric tests are when your data is a metric data. What is a metric data? It's from a scale of 1 to 5, 1 to 7, 1 to 100. Continuous data. That is metric data. When your data which you are analyzing are metric data, you use parametric tests, right? So your correlation, your regression, all of them are, parametric tests. Your T, Z, these are all your ANOVA. These are all your parametric tests. Non-parametric tests are when you are, using a nominal, data, when you are using rank order data, one nominal data and one interval scales data. So your chi-square test, Mann-Whitney test, Kruskal-Wallis test, these are all non-parametric tests. So, so, okay, now let us quickly look at, okay, now you have, okay, do you want me to explain this sum to you? So there is a chi-square sum here. It is now almost sure that I will be, next class also I have to teach data analysis to some point. Do you want me to explain this chi-square test to you? So this is manually done. This can be done, this can actually be done very easily using SPSS also, or a software. Okay, so I'm going to just explain the chi-square test to you. So what did I tell you? What is chi-square test is? Chi-square test is a fitness of, goodness of fit. Say a particular kind of a nominal variable and an outcome, right? So let us look at the example here. A researcher has the data for the preferences of men and women regarding the joint and nuclear family. So what do men and women think about joint and nuclear families? So, so someone has proposed that. So they have a null hypothesis and alternate hypothesis. What is the null hypothesis? The opinions of men and women regarding the type of family are the same. There is no difference. There is null. The opinions of men and women regarding the type of family are different. That is alternate hypothesis. So they went and collected data, right? So how many men they went to? They, joint family, nuclear family. So joint family, 96, women 170, nuclear family 35, women 36. Now what did they say? Let us write. A researcher has the data for preferences of women and men